Action.
Thanks, Margot. Hello, NESEA. We're here in Brooklyn. We're in front of an address 116 Grove Street. We decided to turn lemons into lemonade because we're doing this virtually. I thought, why not just do a walk through our construction site? And maybe this will be the beginning of a lot of people showing their jobs via a video walkthrough. I miss all my friends and my colleagues at NESEA, and I hope we can get back together again soon. I'm sorry for the mask. I want to thank Betsy Pettit, who made this beautiful mask for me. I also want to thank Nia Wilcox and Kelsey Page, two talented staff members of mine who are behind the camera today. You may get some glimpses of them as we walk through the building. They were so looking forward to their first NESEA. So, as I said, we may break the third wall for this rough, seat-of-the-pants, 30-minute walkthrough. So welcome to Casa Passiva. This project is passive house performance with tenants in place. The project is meant to help the tenant experience during the construction of this passive house project. It will be certified by FIAS, and the project was developed well before anyone knew about Energy Strong here in the United States. It was developed from my own experiences and innovations and my work with existing construction and new buildings. It was also developed because of the trips that I took with the NESEA travelers over the last few years to Germany, Austria, Sweden, and Denmark. I want to thank Riseborough, who is the owner and sponsor of this project, for their innovative thinking and financing, specifically Scott Short, Ryan Cassidy, and Emily Kurtz. So this project is 12 buildings, 144 apartments. Added to the scope of passive house is a complete interior renovation, and the energy work added $40,000 per unit to the construction cost. I see this job as three types of work. The work that's exterior to the apartment, which is mechanical system, enclosure, and new electrical service. The work on the interior of the apartment, which is the renovation, new kitchen, floors, paint, and electrical upgrades, and new bathrooms. And then things that happen in between the two renovations, like the ERVs and the refrigerant lines. And we're going to go through all of that in a lot of detail in the next few minutes. Also, we've had a complexity with COVID-19. We had to get a special permit for affordable housing, but we were able to continue with the exterior work even when we couldn't go inside the building. Now we have some restrictions on doing the interior work. The construction workers are only allowed to have one person for every 250 square feet inside of each apartment, and that's presented its own challenges. We will start walking through the entire building, but first let's take a look at the front facades. So as you can see, we have 4 masonry buildings in a row, and the camera will pan all the way down the street to show these 4 buildings. These are 120 Grove, 116 Grove, 110 Grove, and 104 Grove. You can see that we've started window replacement, and we will get more detailed with that whole replacement technique. The building is going to be sheathed in ephes ultimately after all the windows are installed and we get our gold coat, which we're using as our air barrier, on the exterior of the building. So let's go inside. So the building will receive new front doors that are energy efficient. Here's a look at the public hall. Right now we have our technicians here that are installing the new cable wiring. We had to remove the cable on the outside of the building because of the recladding. We also have, no problem. We also have new mailboxes here. This turns out to be a very complicated transaction that happens here in New York City. These are the new mailboxes. We have the old mailboxes over here. And while we're transitioning, people are using their old mailbox. There's a very important key that goes into this mailbox that needs to be delivered by the post office for people to get their mail delivery. So we're going to head outside into the fire passage and take a look at some of the work that's going on outside. And after we're done with that, we're going to go up the stairs. So we're out in the fire passage of this building. You can see Mia. And we're going to walk down the fire passage. So what you see are the scaffolds that are set up in order for us to do the exterior work. And we're going to go all the way to the rear yard. You can see on the walls the air barrier, Stowe Gold Coat. The window on the interior will be removed and then the sash will be put on. So we're installing a new window frame outboard of the existing window. This allows people to still have their fire escape access, their air conditioners, and they can have their windows operable, which they wouldn't be able to do if we just installed the full window here because the casement windows are in-swing windows. So let's move on to the backyard. So you can see down the line here, we have scaffolding set up all the way down the back, and there's courtyards that turn to the right. We have scaffolding all set up inside of here for the window install and for the exterior work to be done. You're hearing some noise in the background. This is ductwork install. We'll show you that shortly. Here's a complete window installed. Frame and sash was installed because this was our sample apartment. So we're going to take a walk up the scaffold. So we're going to show this in more detail in other parts of this video, but you can see here the ductwork that's coming down from the roof and getting installed. These ducts are delivering either supply fresh air from the ERV or they're returning exhaust air from the ERV. The ERV is up on the roof. Let's continue walking. Stop here for a minute. Here we have our air barrier. This is a product by Stowe. It's called Stowe Gold Coat. We've used this successfully on a lot of new construction, and we've met our passive house air tightness. So we coat this building with the Stowe Gold Coat, including the sills and the lintels. Everything gets covered, sealed up. It becomes one homogeneous surface now. The building is going to manage its water differently after we're done. Then the window frame is installed here, and between the two, to seal the joint, is Stowe Rapid Seal. This Rapid Seal makes it so that now we have a complete air barrier all the way to the window frame. And the window frame is installed here without the sash. Because the existing window is still here, we don't want to create a situation where rain could fall and get trapped inside between these two windows. So we don't complete the air barrier at the bottom of the window. We leave that open, and when this window is removed, the existing window, we seal it from the back side. When the EFIS comes to coat this building, it will come to about 1 inch into the Schuko frame. They call that over insulation, and that way our joint is covered, so it's never subject to UV or thermal exposure. It will be covered with the foam, which makes our joint nice and hardy for many, many years to come. So all these facades, once the ductwork is done, are going to receive 8 inches of foam EFIS on the exterior. And moving up one more level, you can see where they're coming from the rear. So from the ERV is coming a manifold with 4 ducts coming down, and each one of these ducts is going to its own room. This is a stack of living rooms, so one duct goes into each living room, going all the way down the stack, and so on and so forth for all of the ductwork that you see on the facade here. So we'll be showing some of this stuff in more detail from the roof shortly, but I want to go back down into the apartment building to show what's going on inside of the apartment. Okay, so we're back in the building. Let's take a walk up the stairs, and we're going to show you what's going on inside of the apartments. So the existing windows here in the stairwell will be replaced with new Schuko windows with thermal performance, high thermal performance. There's also, if you see that big box there, this is the new cable TV wiring that we need to have in order to remove all the wires from the outside of the building. We'll be getting new LED lighting in here. And the entire stairwell will be cleaned, new paint, and will be transformed. Okay, so we're going to take you into our field office here. We've been able to take one of the apartments and make a field office. And we used to have our meetings in here pre-COVID. Now, sadly, we don't. So this is the apartment that is finished. We have the new windows, we have the new sashes in here. The floors have been sanded and polyurethane. In some of the apartments, we're putting down click flooring to cover bad flooring. There's a new kitchen here and a new bathroom. Part of the energy piece of this is the new induction range. So this range has been the subject of a lot of discussion with the job team, to the point where we made a video of how to use this range. It was done by Mia and Kelsey. And here's a clip.
Hello and welcome. This is an intro video about your new induction range. In this video, we will be showing you how to use your induction range to the best of its abilities. Thank you.
These warnings are not a substitute to not read the manual. We're just reiterating some things that might be overlooked. Please use cookware with flat bottoms. To get the best results when cooking, use the stovetop heating element that fits the size of the pan being used. Below each heating element is a copper coil. When the stove is turned on, the electricity is sent to the coil, making it into a magnet. So that's what creates the heat in your cookware. Magnet test to see if the piece of cookware will heat up on your induction cooktop. If the magnet clings firmly to the bottom of the cookware, it will work on your induction cooktop. Only use recommended cookware. Don't worry, your Dutch ovens and your cast iron pots and pans still work. Just do the magnet test before using them.
10 minutes.
Sorry to interrupt you, Kelsey, but did you guys catch that buzzing sound? At the highest setting, the magnetic field over the induction cooking element may cause cookware to vibrate. To hear a slight buzzing or humming noise is normal. Back to you, Kelsey.
Thanks, Nia. The high setting fun fact, electric stoves heat more efficiently than gas stoves, meaning the kitchen will stay cooler when the stove is on. Shiny aluminum and non-coated bakeware is best for even heating. It is suitable for all baked goods. Recommended cooking temperatures and times are based on shiny metal bakeware. Dark bakeware cooks hotter than shiny bakeware. Reduce the cooking temperature by 25 degrees. Bake button turns on the bake feature. Broil button turns on the broil feature. The oven light function turns on the light inside of the oven and also turns on when the oven door opens.
We're going to take a look inside of a newly renovated apartment, and I can show you the stuff that's happening on the inside and the stuff that's happening in between. So we'll start here in the bedroom. You can see the new windows that are installed. And then just to the right of the window is a hole. So you saw this courtyard when we were outside on the scaffold, and this hole connects to the outside. This hole was made by a hole cutter through masonry from the outside to connect to the interior, and this is where the duct from the ERV up on the roof is going to come in and be a fresh air supply for this bedroom. In order to get the ductwork from the outside come to the inside, we're using a stainless steel piece that's more normally used for sealed combustion furnaces. But it has a gasket on the inside, so we can embed this into the wall, and when we're poking our exterior round into it, it will seal at the gasket. The ductwork will be sealed against the outside to keep our air barrier. And it will come through and be sealed to the inside, and then we get a grill. So we have no air leakage between the inside and the outside with the install coming through the wall. Here is our ductless split head. The outdoor part of the unit is up on the roof, and the refrigerant lines come down, poke through the exterior wall, and connect to the back side of this ductless split unit. Every apartment has their own unit, and we're going to be able to monitor the energy use of each one of these condenser units up on the roof because we're sub-metering all of the electricity. So we're going to walk through every room, and I'm going to show you the general anatomy of the mechanical system. Very similar to what we're seeing here. We have a fresh air duct, and we have the ductless split system. This is a bedroom. Here's our living room. Again, we're going to serve fresh air into the living room. And we have our ductless split head here. In the kitchen, our hole is made, and this will be an exhaust. So we're supplying to the living rooms and exhausting
from the kitchens and the bathrooms. In the bathroom right now, you can see a tiny hole up in the wall. That's a pilot hole for the hole that they're making for the exhaust for the bathroom. I think they're probably going to have to move that down. But what they do is they make the hole from the outside, and they have a pilot hole that comes through and tells them where it is on the interior. And then finally, in this last bedroom is a ductless split head and fresh air. So we are exhausting out of the kitchens and the bathrooms, and we're providing fresh air to all of the living rooms. So that's bedrooms and living rooms. Now, something unusual that's going on here is that instead of ventilating unit by unit, we have an ERV for this line of bedrooms. And this line of bedrooms is probably connected to this line of bathrooms so that we can equal the supply and return with the ERV up on the roof. And we're going to show you more about that. We're going to go up to the roof.
So a lot of stuff to point out here on the roof. It looks super complicated right now. So I guess first I'd like to proudly announce that this chimney is no longer going to be in use. We're making our domestic hot water with a sealed combustion boiler that has a direct vent to the outside down at the cellar level. So goodbye chimney. The next thing is that we are going to be doing an upside down roof here. It's called an Irma roof. And we're using this really great product that a friend of mine at the Housing Authority turned me on to called T-Clear. And it's XPS foam with a concrete top on top of it. So we can lay this down in panels. And what we'll do is we'll put some layers of foam first, and then we'll put this layer on finally to give us 8 inches of foam insulation completely across the top of the roof here. So this roof is going to get another layer of roofing, and that layer of roofing is going to get moved across the roof here and then up to this material, and this is going to be our new parapet wall. We're building out the parapets so that we can run our refrigerant lines and our ductwork and hide it all in the parapet, which will then be coated with EFIS. So in the end, you're going to see a very simple roof. It's going to have our ductless split condenser units. Most of them are going to be mounted onto the parapets. And we'll have our ERV boxes. And we'll have a clean roof without all the stuff that you see right now. So let's go over and take a look at how some of this ductwork is configured. So these ducts are coming out of the ERV, and then they're waterfalling down the side of the building and stopping at each floor with one duct, the rest of them continuing on all the way down. These ducts are connected to larger square ducts, and those square ducts are connected to the ERV. And we're going to show you a sample of how we're going to manage the ERVs up here on the roof. All right, we searched in vain for an exterior ERV that had a small CFM and had the EM motor. We couldn't find anything that worked, so we ended up using an interior unit. And this is a new unit by Renew Air that goes from 80 to 230 CFM, EV Premium from new air. And this is set up ideally so that from the top of the unit comes our outdoor exhaust and our outdoor supply air. And then on the bottom, out the bottom are the ports for the air, for fresh air and exhaust going down into the building. So this, of course, is an interior model that we have to make exterior, so we have to both insulate it and waterproof it for it to be up on the roof. And to do that, we came up with the idea of using one of these very large insulated shipping boxes, which we found online and seemed to be really ideal for what we want to do. So this box is oversized and we're going to have to cut it down to get it to be the right size. But the idea here is that the unit is inside the box. The green is our exhaust air going out, and the blue is our fresh air coming into the unit. I'm going to take this box apart and show you the inside. Someone has used the inside of this as storage. I have to pull this out. So let's take a look at what goes on inside the box. This is a mock-up of the unit in plywood. So at the top here, the green duct is our exhaust. The blue duct is fresh air. Here's the unit. And then coming out of the bottom of the unit are the supply and the return to and from the house. Now these ducts are going out of the insulated enclosure. They're going to move underneath our insulated roof surface, and they connect up to the ductwork that's on the parapet and then down into the unit. And you can see this second one over here coming out of the bottom of the box, connecting to another duct, and then that is going down into the unit. So this ERV is not serving a single apartment, it's serving stacks of rooms that need supply and exhaust, and the supply and the exhaust are calculated to be equal. Come around to the front here, you can see that there's a lot of extra space in our box, so we're going to modify these boxes to chop them down, but they turned out to be really the ideal product for us to enclose this ERV, and they will be coated on the outside so that they have long wear up here on the roof. So the idea here is to make this ERV look like a friendly robot. And after we're done with the modification of the box, it'll be thinner, and we will have one arm coming out of one side and one arm coming out of the other. The reason I want to do this is that there are often in our passive house jobs very few photo opportunities that a photographer really wants to latch onto. So I wanted to make it so that people love the ERVs. They look at the ERVs, they want to know more about the ERVs, in lieu of our typical green building photograph, which is a green roof or a solar panel. Two things that are really the last things that you should put on your building after you've done all of this other work. So you see a lot of condenser units up here. These are the outdoor side of the ductless split systems, the heads you saw inside of the apartment. So these are going to be located roughly adjacent to where the heads are downstairs. They're going to be mounted to the parapet walls. These are the brackets that they will be mounted on. And then from the back side, which you can see right here, come the refrigerant lines. They're going to go however they need to go in the buildup of the parapet and then down the surface of the building and poke through into each head location inside of the apartment. So this big bad boiler is going away. We're going to remove it. Its job up to now has been to make the heat and the hot water for the building. We're going to replace it with the ductless split systems up on the roof that are delivering heating and cooling to the apartments. So the heating and cooling will be electric. But we will be making domestic hot water with gas, and we are going to set up a new sealed combustion boiler and storage tanks in a small amount of room. We'll basically be building that system around this existing boiler. And then when that is complete, we will bring piping to the existing water main, and then in an hour or two, the connection to the new system will be made to the piping upstairs, and then this whole thing will be removed. And as I said up on the roof, the chimney will be gone. No more need for the chimney. So I hope you've enjoyed our tour today. If you would like to get in touch with me, you can reach me at chris@benedictra.com. That's CHRIS. And I wish you all happy buildings, happy passive house, and safe and healthy times ahead.